Okay, Physics Day 3, relative motion. So with this, we have the problem of a quarterback and a wide receiver for our example problem. We are going to run out of space no matter what I do. Actually, yeah, we'll do it. So we've got our quarterback. Quarterback starts at the center of the 50-yard line. So we have our 50-yard line. First thing he does is they move back 6 yards, but not straight back. They move 10 degrees to the left of straight back. So this is left. Oh, good grief, this is off the screen. This is left. This is right. So they move back at 10 degrees off of straight back, to the left of straight back. So that is 10 degrees to the left of straight back. And the distance they go back is 6 meters. Perfect. The wide receiver is initially, so they've got their wide receiver here, is initially 5 meters to the left of, to the right. Oh, good grief. I'm doing everything in meters. This is yards. I apologize. We're talking football. You'll be thankful that I prefer meters so heavily when we get later in the class. So you're 5 yards to the right of the quarterback, and they're going to run 25 yards at an angle of 45 degrees to the left of straight forward. So they are going something like so. So this is going to be 45 degrees. And this distance is 25 yards. So at the end, when this pass is completed, wide receiver is here, quarterback is here, and they are throwing the ball. Uh-oh. This distance. And we are asked, what is the distance and what is the path of the ball? So by that, I want to know this distance and I want to know the angle that it is moving at. So with that, what we're going to do is we are going to get used to splitting everything into what is happening in the x-axis versus what is happening in the y-axis. Okay, first thing we're told about is this quarterback movement. I'm going to label everything forward as positive and everything to the right as positive. I think, yes. Oh, nope, nope, nope. I did not label that this way in your piece. It looks like I labeled everything to the everything to the left is positive. We could solve it either way. I just want to be consistent with the worksheet that I'm giving you guys. Okay, so quarterback movement. Quarterback. He is going 6 yards in this direction. What is that in the x? We are going to have to always just draw our little triangle here. We've got 10 degrees right there, and we have 6 yards right here. So in the x, this is the x. So this is positive x, this is positive y. That looks more like a G, I apologize. So in the x, we are going to have, this is going to be the sine of 10 degrees is going to be equal to this, we'll call it QB in the x, divided by the hypotenuse. So opposite over hypotenuse is sine. So this distance for the QB is going to be 6 times the sine of 10 degrees, which I have, oh, sorry. And, sorry, 6 times sine of 10 degrees, which is going to be equal to 1.042 meters. And this is going to the left, and we said left was positive, so this will stay positive. Perfect. And the portion of the QB in the right, in the y, downfield, so he is going to be cosine of 10 degrees is going to be QB in the y divided by 6. So we have 6 times the cosine of 10 degrees, which is going to be equal to 5.909 meters. And this is going backwards. We said forwards is positive. We want to go down the field. So this is a negative play. So we have negative 5.09 meters. That is our quarterback. We now have our wide receiver. I think it's supposed to be both capitalized. I apologize. Our wide receiver starts 5 meters to the right. So that is easy because there's no triangle here. He's just negative 5 meters because positive is to the left. And it's got no downfield position. We don't have to break that up at all. And then last thing we have to do is we have to get the his run in. So I will go ahead and draw that triangle out, except that's not the triangle that I have drawn. It would work just the same because both of these angles would be 45, but better not get confused by the fact it's 45. So 45, and this is 25 yards. So this portion right here is in the x. This portion right here is in the y. So the portion in the x is going to be the sine of 25, sine of 45 degrees is going to be opposite, which is my wide receiver in the x divided by hypotenuse, which is 25. So we have in the x, he goes 25 meters times the sine of 45 degrees, which is going to be equal to 17.678 meters. And it is going to the left, and we said left is positive, so this is another one that is positive. And then we have cosine of 45 degrees is going to be equal to wide receiver in the y divided by 25. We get 25 times cosine of 45 degrees. And that is going to, again, be 17.678 meters. And again, we're going downfield, so this is positive. We have split down everything that we know, everything that they've done. Now the question is, how do these get put together? And we're going to not think of it formulaically right now. We're going to think about it as a equation, as a logic question. So how does this 1.402 meters impact the distance that he has to throw the ball? How does this negative 5.909 meters impact how he has to throw the ball? And we're going to ignore the fact that it is negative. So we want to find x total, and we want to find y total. So if, let's say forwards, because forwards is positive. If the wide receiver and the quarterback were right on top of each other, and the wide receiver ran forward, and the quarterback ran forward, and the quarterback threw the ball to the wide receiver, he is going to have to throw it not as far because of how far he ran. And he will have to throw it further because of how far the wide receiver ran. Correct? So any distance the quarterback runs decreases how far he has to throw it. So if he runs forward and throws it, he doesn't have to throw it as far. Any distance the wide receiver runs, if the wide receiver runs further forward, the quarterback is going to have to throw it further. So our total x is going to be the wide receiver distance in the x minus the quarterback distance in the x. And same is true for the y, so we have the wide receiver distance in the y minus the quarterback distance in the y. And I'm going to start with the y because that's what I was talking about. It's a little bit easier to show. So the wide receiver in the y has gone 17.678 meters downfield, and the quarterback has gone negative. I'm going to have to write it underneath. You guys don't see that much of the board. Negative, so minus a negative 5.909 meters. So we're like, oh no, the quarterback's actually making it further. That's because the quarterback is going in the negative direction. So that comes out to our y total of 23.587 meters. Okay? Now the x total is going to be the wide receiver in the x went 17.678 meters. And he also has a negative 5 meters in here because he started 5 meters to the right. So we got two positions. It's as if he ran 5 meters to the right and then ran that. So we are just adding those together. So adding negative 5 and the 17. And the quarterback, we're going to subtract a positive 1.042 meters. Because while the wide receiver has gone way over this way, the quarterback went a little bit that way, so he doesn't quite have to throw as far. And I get a value of 11.636 meters. So all in all, this throw has to go a total distance of 23.6 approximately meters, downfield and 11.6 meters to the left. Well, how can we get that total distance and position? We can draw it out. So we had this line. I'm going to redraw that line as a combination of two lines. This is the distance in the y, and this is the distance in the x. And here, this is exactly this line. These are the same thing. That is how far he has to throw it. So in the y, that number was 23.587 meters. And in the x, that number was 11.636 meters. Now we can leave that up. It's not in anybody's way. So we want to find this distance right here. That was one of our pieces. I would normally write out my what to finds, but we're already running out of board space. So how can we do that? Well, this is a right triangle because any distance downfield is perpendicular from any distance to the left by definition. So what I can do is I have a right triangle, and I know for a right triangle, a squared plus b squared is equal to c squared. Right on that lovely white square that I don't know how to get rid of. A squared, so we've got 11.636 meters squared plus 23.587 meters squared is going to be equal to my distance squared, or my distance is the square root of all of that. That number comes out, the distance they have to throw it is going to be equal to 26.301 meters. Lots of trig, but you guys can handle it. I believe in you. Now we have to find either this angle or this angle. We're going to go with this guy right here. And that guy is going to say that the tangent of this angle, so tangent, and we're going to call him theta, is going to be the opposite, so 11.636 over the over the adjacent, 23.587. So the tangent inverse of all of that, theta, comes out to be equal to 26.258 degrees. And that is 26.258 degrees to the left of straightforward. We could say that we could solve for this one. We could call it phi, and tangent phi would be equal to, this is x, this is y. That's going to be x, which is, I'm just going to write in the number, 23.587 divided by 11.636. And that's going to come out to whatever 90 minus this number is. So that is 63.742 degrees. And that will be 63.742 degrees straightforward of left. Or if we're talking about if this is north and this is west, this would be 63.742 degrees north of west, or 26.258 degrees west of north. So that is that guy. Got a little hole for my face here. Hopefully that makes a lot of sense. We're easing a little bit into trig, but this idea of having that vertical line and having everything in the x on one side, everything in the y on the other side is absolutely something that will be super helpful for you as we get into next class period and everything after that. Really make sure you keep track of what is happening in the x, what is happening in the y, so that you don't intertwine those guys too much. Hopefully that's helpful. Take care.